Hi, I am Arib. You are watching my YouTube channel. Control cable. Definition. Control cables play a vital role in modern technology and infrastructure, acting as the nervous system for various control mechanisms. These specialized cables enable efficient communication, seamless automation, and safe operations in industries and daily applications. Whether it's transmitting signals in a manufacturing plant or ensuring precise control in a smart home, control cables are indispensable. They improve efficiency, enhance safety, and support innovation. This article explores what control cables are, their applications, manufacturing process, and the factors that ensure their quality and safety, offering a comprehensive understanding of their significance in our lives. What is control cable? Control cables are specialized cables designed to transmit signals or regulate systems in various applications. Unlike power cables that transfer electricity, control cables are primarily used to relay low-voltage commands, making them essential for controlling machinery, industrial processes, and automation systems. They come in various types and configurations, often consisting of insulated conductors bundled within a protective sheath. These cables are engineered to resist environmental factors such as heat, moisture, and mechanical stress, ensuring consistent performance in demanding conditions. Control cables enable precise control and are indispensable in industries like manufacturing, construction, and transportation. The application of control cable. Control cables are used across a wide range of industries due to their versatility and reliability. In manufacturing plants, they transmit signals between control panels and machinery, ensuring smooth and efficient operations. In the automotive industry, they are employed for controlling systems like brakes and air conditioning. The construction sector uses control cables to manage elevators, lighting, and HVAC systems. Even in residential settings, control cables facilitate smart home technologies, connecting devices like security cameras and automated thermostats. Their ability to maintain signal integrity and withstand harsh environments makes them essential in these areas, supporting both functionality and safety. How control cables work? Inside a control cable, you will find multiple copper conductors. These are the wires that actually carry the signals. Each conductor is individually insulated to prevent crosstalk, signals jumping from one wire to another, and in many cases, the cable includes shielding to protect against electromagnetic interference, EMI. This is crucial in environments filled with electrical noise, like factories or power stations. So, how exactly do they work? Inside a control cable, you will find multiple copper conductors. These are the wires that actually carry the signals. Each conductor is individually insulated to prevent crosstalk, signals jumping from one wire to another, and in many cases, the cable includes shielding to protect against electromagnetic interference, EMI. This is crucial in environments filled with electrical noise, like factories or power stations. When a system sends out a signal, say, from a control panel or PLC, programmable logic controller, it travels through these conductors to the relevant device. This might be a motor, actuator, sensor, or relay. The control cable ensures that the signal gets delivered clearly and instantly, allowing the machine to react precisely. Some control cables are designed for fixed installations, where they stay in place without much movement. Others are made to handle continuous flexing, like in robotic arms or moving conveyor systems. These flexible control cables use fine-stranded copper and durable insulation materials to prevent wear and breakage over time. Key features that make control cables work reliably include multiple cores for sending several signals at once, color-coded insulation for easy identification during installation, shielding, foil or braided, for EMI protection, durable sheathing for protection against heat, chemicals, or moisture. In essence, a control cable is engineered for accuracy, speed, and stability, making it an essential part of any automated or controlled electrical system. Types of control cables. Control cables come in all shapes and specialties, but they all have one job: keeping systems running smoothly and signals flowing accurately. Let's break down the main types in the simplest way possible, so you know exactly what's. Shielded control cables. These are your go-to when things get noisy. And by noisy, we mean places full of electrical buzz like factories or power plants. The shield, a foil or braided layer, blocks out interference, so your signals stay clean and uninterrupted. Unshielded control cables. No shield, no problem if you are in a calm electrical environment. These cables are simple, light, and cost-effective. Perfect for basic setups that don't need extra protection from interference. Use it when there's little to no electrical noise around, like in residential buildings or simple control panels. Flexible control cables, built to bend, twist, and keep moving without breaking a sweat. These cables are made for motion. Think robotics, moving conveyor belts, or anything that doesn't stay still. Use it when the cable needs to move constantly, especially in automated machines. PVC insulated control cables. PVC, polyvinyl chloride, is a reliable all-rounder. It protects the cable from moisture, chemicals, and mild heat. Not the toughest out there, but solid for everyday use. Use it when you need a durable, budget-friendly cable for general indoor or outdoor use. XLP insulated control cables. Insulation handles higher heat, stronger voltage, and harsh conditions like a champ. Use it when you are dealing with high temperatures or rugged industrial environments. Key applications of control cables. Industrial automation. From factory lines to robotic systems, control cables connect sensors, motors, and PLCs to ensure every movement happens at the right time. They are built to handle motion, vibration, and electrical noise. Building and construction. In commercial and residential buildings, control cables power up lighting controls, elevators, HVAC systems, and fire alarms. They are key to keeping everything running smoothly and safely. Power plants and substations. Control cables are used to send commands and feedback between control rooms, circuit breakers, and protection devices. Shielded versions help avoid interference in these high-voltage areas. Machinery and equipment wiring. Inside machines like CNCs, conveyors, or packaging units, control cables help manage functions like start-stop, speed control, and emergency shutdowns. Flexible types are used when parts move often. Benefits of using control cables. Control cables are not just wires, they're the silent force that keeps operations safe, smooth, and under control. Whether it's a high-speed factory line or a smart building system, here's why these cables are worth every bit of attention. Reliable signal transmission. Control cables are built to carry control signals without interference. That means less noise, fewer glitches, and more accurate communication between machines and systems even in electrically noisy environments. Supports complex automation. Got machines that need to respond quickly and precisely? Control cables make that possible. They're designed for tasks that involve real-time feedback, motion control, and multi-step operations. Safety first. In systems where safety is everything like power plants or elevators, control cables help trigger emergency shutoffs, alarms, and protective functions instantly. They're also flame retardant and built to handle tough conditions. Durable and long-lasting. Whether exposed to heat, chemicals, or constant movement, control cables are built to last. Flexible or armored, they are designed to withstand mechanical stress without wearing out easily. Cost-efficient in the long run. Using the right control cables reduces system downtime, prevents signal errors, and cuts the risk of costly damage. That means fewer repairs, less maintenance, and better overall performance. Choosing the right control cable. Choosing the right control cable is crucial for ensuring reliable and efficient operation. First, consider the environment, whether the cable will face heat, moisture, or wear. In harsh conditions, opposite for cables with strong insulation and sheathing for protection. Next, ensure the cable has the correct voltage and current ratings for your system to avoid overheating or failure. PVC is common for general use, but for tougher environments, rubber or XLPE may be necessary. If you are working with multiple signals, multi-core cables are the way to go, while shielded cables protect against interference in noisy environments. Selecting the right cable ensures longevity and smooth performance for your systems. Cable trays definition. A cable tray is a structural system used to support insulated electrical cables used for power distribution, communication, and control. It provides a secure pathway that prevents cable damage, simplifies maintenance, and reduces the risk of overheating. Unlike conduits, which enclose cables completely, cable trays are open structures that allow better airflow and easy access during maintenance. Conclusion. Control cables are crucial for ensuring the seamless operation of electrical systems, connecting control devices to machinery for smooth functionality. Their ability to withstand harsh environments, extreme temperatures, and electrical interference makes them vital in industries like manufacturing, power plants, and daily systems like HVAC. Selecting the right control cable is key to ensuring your system's reliability and performance. By choosing the appropriate cable, you reduce risks and enhance efficiency. Question. In modern industrial automation systems, what is the primary purpose of a control cable? Choose the right answer. Link in description.